Welcome to episode 19 of Tacit Talk. I'm your host, Conor, and I have a returning guest today. The first, I believe, returning guest solo, because technically you've been on twice. And not just the first returning guest, also our very first guest from, I actually don't know how long ago. I guess I could go look it up. But we have with us Kai Schmidt, who probably most of you know as the creator of the Uiua language. Today we're going to be chatting about updates from Uiua. The last time we chatted, you said Uiua 0.15 would be out either right when we were recording or a little bit after, a little bit before. So I'll throw it over to you quickly. Because I should know this, but I'm a little bit underprepared here. Is Uiua 0.15 out, or is it still coming?
No, it's not out. It'll probably be a few weeks, I think.
Okay, a few weeks. And we've got lots to talk about today. I mean, I was just gushing before we hit the record button about the Stencil Operator, which a few of at least 1,000, probably they're not all watching right now, but they might be listening or watching later. A few of the viewers of this channel will know, because I discovered this during, I believe it was the discussion with Madeline on Tiny Apple. And I was talking about how I have always wanted a specialization of the n-wise reduction where n is equal to 2. And then Madeline just casually said, I'm pretty sure Uiua Stencil does this. And I was like, what? That's not true. You have to use Windows. Apparently Windows is out, Stencil is in. So I made a kind of meme YouTube video. Anyways, we're going to talk about everything that's been new since the last time you were on. But let's start with what is probably, I don't know, is it the underscores or the prefix?
I guess subscripts?
The subscripts, or is it Stencil? It probably is Stencil. But go ahead, throw it over to you, and we'll talk about Stencil for a little bit.
Oh, yeah. So this is mostly based off Stencil from APL, which Adam, the language designer of Dialog APL, convinced me to add. And so here we just got Stencil Subtract, which just gives you the what and what the adjacent differences of all the items in the list.
And does it work the same way for, I guess I should know this, I should have played around with it, because the nice thing about this implementation is some implementations of a 2-wise reduction would apply the binary operation in the order of, your left argument on the left side and your right argument on the right side. Does this like swapping happen just for minus, or is it for all binary operations? Or
so if I don't know if I did like stencil minus or what 3.5. Yeah, well it's like if you took this and put it here, right?
Oh, so that's actually just the way that minus works. And so divide here would give 1.67?
Yeah. Gotcha.
Ooh, that's a nice little formatting feature there.
Yeah, so I've got the VS Code, and so you can see I've got the VS Code extension here. I've also got the native Uiua window over here.
The native Uiua window. Walk us through that. What is that?
If you run, I close this and I run Uiua -W, we open this window and it just shows you the output of your program. And so even if I did like an image, I don't know, let's do like table times dot divide on range 300. So it shows you images and stuff too.
Mm-hmm. Oh, so this won't happen inline in the Uiua files is probably what you're...
No, but this is the same functionality that you'd get from the pad, right?
Right.
Same thing.
Okay, so let me quickly too. This is awesome, but I've realized I've completely put the horse in front of the cart. No, the cart in front of the horse. I always get that expression wrong. Maybe that's because I don't ride horse carts around. Let's go to tacittalk.com quickly for myself. Episodes, we scroll all the way down to the bottom. So you were the first guest, and it was less than a year ago, May 10th of 2024. Do you recall what the Uiua version was back then, plus or minus?
I don't. We could look at the versions, right? Changelog. May, you said?
Yeah, May 10th of the year 2024.
24, looks like we were probably on point 10. Yeah, point
Okay,
10.
so point 10. We're currently on point 14, and point 15 is going to be in the next few weeks. So, I
Yeah.
mean, probably, yeah, the place to start is from, the language designer point of view. I'm not sure if you want to walk us through, point 11, point 12, point 13, or you just want to kind of, in one fell swoop, cover the highlights across those changes, not necessarily, by version.
Yeah, let me pull them up in another window here so I can look at them.
Because there's some exciting stuff. Obviously Stencil. I mean, Stencil it's a small thing, but it's very near and dear to my heart because as I was chatting with Madeline, as I said when I was chatting with Madeline, I think NY's reductions are extremely common and important. And especially the two-wise reduction. Like I always bring it up that in the Q language, they actually have a keyword prior for the two-wise reduction. And then on top of that, they have two different specialization keywords, different deltas for the minus two-wise reduction and then not equal to two-wise reduction. And I get that Q a lot of the times is used in finance applications. And so if you're looking at, financial time series data, it's a very common thing. Like if you think about you need to determine when a stock goes up or down, that's a deltas operation on, your closing prices of some financial assets. But still, I think it comes up all over the place. So thrilled that Stencil's there, but there's a bunch of other stuff, including the subscripts that I mentioned, but other stuff too that I'm sure is not even on my radar, and excited to hear about it all.
Yeah, so two of the things that the language is moving toward, well, one of the things that we've been focusing on a lot is making the stack nicer to work with, making it more clear when values are created, when they're used. We've got like a bunch of new combinators that express common patterns of stack usage. And also, there's some experimental stuff I can show too, but I don't know if you've seen them. We've got with. Also, you knew about like on, right?
Yes, and I'm excited we're going into with because a lot of the times, because I'm a Uiua, we'll call it novice, like beginner, in that when it comes to with and by, a lot of the times I know I want something that has an equivalent in BQN, but then I will just one by one try like with, by, because I know that like they're slight variants of each other the same way that like before and after are variants of each other. So maybe out of this, I will no longer have to guess and I can just reach for the one that is the one that I'm looking for.
Yeah, so there's actually a new tutorial on these, but I'll just go over them quickly. So on and by have been in the language for quite a while now. On just keeping the top stack value on the stack and by keeping the bottom value below the outputs on the stack. So hopefully you can see like the symmetry in these outputs.
Right, yes.
Now there's with. And so that's going to keep your bottom value on top of the stack here. And there's also off. That's going to keep your top value below the output on the stack. Another way to make this simpler to see might be to do like a couple instead of plus. So I'm coupling 3 and 5 together in all of these, but you can see which of the inputs is kept where on the stack, basically.
Right, and this is the full set of these basically because you have
these form like an entire class,
right.
Basically. I actually have a tutorial that has like a table of them. There's one more that I use a lot, and it's called below. And that's going to keep both of your outputs both of your inputs below the output. Or not just both, but any number of inputs.
So yeah, to describe this to our audio listener, and once again, I feel like we're on episode 19.
With the audio, yeah.
Yeah, episode 19, although of which, I don't know, 6 or so actually aren't these YouTube interviews. This is on YouTube. If you want to, watch online, I would say this podcast, out of all of my podcasts, definitely is the one that you should. I mean, it's actually the only one with a video component. So what am I talking about? It's the main one you should go and watch on YouTube, whereas the other ones don't have YouTube components. But we're looking at basically two values, 3 and 5, and then we've got on, by, with, and what was the last one called? Off, and then below is
off, and then below.
Yeah, and all of these are basically combinations of applying a binary operation and then keeping one of the values. And seeing as we have two, you can keep either or, so there's two options there. And then which order do you keep them? Before or after the result of applying the binary operation? And then below keeps both values. And you could think that there was some analog to that, right? That where the values kept.
There is. It's called above. It's experimental because because fork exists. It's actually not that useful. Because
fork exists. Oh, right. Assuming that you would want.
For example, if I wanted to do like plus below couple, so I've kept the outputs. I've kept the inputs above the output, and then I've added them together. When you could just do that with fork plus couple.
Right. That makes a lot of sense.
I mean, theoretically, there are situations where it's useful, but they're not common enough, I don't think. So I've just left it experimental for now.
So the thing that I'm thinking right now is in the cases, and also too, for the audio listener, and also actually for the visual listener that is maybe less familiar with BQN, the on glyph corresponds to BQN's after, which is a kind of a jot with a hyphen on the right. And then the with glyph corresponds to BQN's before, which is a jot that has a hyphen on the left that are attached. And then was it by and off?
This is with and off.
On, by, with, and off are the same kind of patterns, but instead of a jot, aka the little circle, it is kind of like a mini less than sign.
It's like an arrow tail without the arrowhead, kind of.
And so the ones where you are not swapping where the argument came from. So in this case, it's by, and I think it's actually it's the first two. Yeah, it's on and by. These correspond to basically the I want to say it's the D and delta combinators potentially, where you are.
Here, this table might be helpful.
Yeah, I was going to say we could try and do it without the table, but we'll see how close I got. Or this is a different table, actually.
This is keep the something argument, something the outputs. So, for example, on is keep the first argument above the outputs. By is keep the last argument below the outputs. Below is keep every argument below the outputs.
Right. Yeah, so it's kind of like a exhaustive set of operations. TBD though, because above, like you said, you might not add. Due to the fact that it's kind of redundant.
And so this is on the website. This it's called even more stack manipulation. It's like in the other tutorials section, but it shows you this table and then it gives you intuition of like when you would want to use each of these things, right? Because usually you're not just doing like by or on something. You're putting usually a dyadic function to the left of this thing.
Right.
So, for example, if you did like divide on range, you get your like list from 0 to 1 with that many numbers.
Right.
And with and off, you usually use with two dyadic functions. So if I go back to this, there's like cases when you'd use these.
Yeah, the classic example that comes up in my brain, at least, when dealing with this kind of operation, where you're applying a binary op to two things and then using that result with only one of the two arguments, is like what corresponds to like a sum if operation in Excel, where you want to look at some other range and potentially compare it with your target range that you want to sum. You do some kind of comparison there, and so it's like you want to sum some values that are greater than 100 or something like that.
So if in that vein, if you had like, I don't know, right? If I took, I don't know, we could do our less than 100, right? And it gives our mask.
Mm-hmm.
But if I do by less than 100, now I've got both of these on the stack. And now I can do, I don't know, probably my key, right? And then some.
Right. Yeah, stuff like that. Yeah.
So yeah, usually you're going to have like a dyadic function to the left of any of these.
Yeah, and I probably have told you this before, but seeing as keep is on the screen now, I do love. I honestly love a lot of your choices for glyphs. I've been spending more time with cap, and I find myself gravitating more towards the original APL set when it comes to certain things. Like probably in BQN, my least favorite choice is the range operator. Once again, it's not even for...
You mean the up and down arrow?
Yeah, the up and down arrow, where it used to be iota. And I don't even have... I was talking to Madeline. We were messaging after our podcast recording on Tacit Talk, and we were talking about some glyph choices. And I think it came up because on one of the array casts, I was talking about my affection for the vertical rotate glyph versus the horizontal one. But that's not actually, like, Marshall pointed out that, a lot of the times you're doing that on rank 1 vectors. And so he provided a practical argument. Mine's not even like a prac. I just like it better. I just have like a soft place in my heart, which is the same thing for iota. That being said, in Uiua, there's a ton of glyphs that you have been like the first to choose, at least from what I've seen. Keep is one of them. Outer product, I know, is another one. And in general, too, you have kind of like a square. There's a bunch of square glyphs. I tend to like those.
A bunch of squares and a bunch of circles, yeah.
Yeah, I tend to like those better than the APL. Like the APL, I didn't actually know. I think I learned this the other day, that the quad is actually, the ratio of the quad is like the golden ratio. I think that was
if your font's correct, assumedly.
Yeah. If you have the right fonts installed.
I specifically didn't pick, like, because when I'm picking these glyphs, right, I'm just browsing the font.
Yeah.
I'm browsing all the characters that are available in the font, and there's lots of times when I'm like, could I do one of the APL quad symbols? And I'm like, no, they're too tall. I want squares.
Yeah, I mean, that's in cap. That's well, when I discovered an omnibar that you can search across different glyphs in the language. Outer product is one of the least agreed upon, or like the most diverse options. And I will say, like, caps is better than the original APLs because it's a single glyph, which is the rectangle with a jot inside of it. But it's, in my opinion, far inferior to the the square that we're looking at right now on the screen, which just looks like a 2x2 matrix.
I mean, yeah, that's what it is, right?
Yeah. It's literally was renamed table by like half the languages, I think, including Uiua.
Speaking of new things, so there's a newish related modifier called Tuples.
Mm-hmm.
And so if I do tuples plus, and then I think I need to do, just kidding. I need a tuple size 2. So this is similar to table, except it's giving you the not all combinations. In this case, it's doing, actually I'll do tuples couple. Or, just kidding, tuples less than. There we go. So now this is why we put a less than here. It's complicated, but basically this is giving you all combinations of things from that thing. So if I've got my 1, 2, 3, but if you were to look at like what these glyphs are, so if I took, like, I don't know, range 10, here's all my tuples, and then I did like a where on this, or an unwhere, you see that, like, you get that triangle shape in the output.
Wow. Okay, we got to talk about this for a sec. So is the binary... So first of all, this is called tuples, and it is a square with a diagonal from the top left to the bottom right for the audio listener that can't see this. I have never played around with this glyph, other than having probably seen it and ignored it in the icon bar at the top. And so you pass it a binary operation, and then it returns you all two tuples that...
What the binary operation does is it compares all the indices of the items in this list, right? Mm-hmm. Here I'm getting tuples that are of size 2, and so I'm taking all pairs of indices, and I'm comparing them with this function, and if they pass, we put that pair in the output. So if I look here, we've got 0, 1, 0, 2, 0, 3. And this is for the case where you're trying to, like, do a table, but you don't want to, like, say if you have a what is it, commutative? If you have a commutative function on your table, and you don't want to do extra work, you just need like combinations of something, right? That's a case when you would use this.
No, this is God, I love these conversations because I always end up learning stuff. This is brilliant because I literally have in a BQN file in my little set of tiny BQN libraries a file called fun.bqn. And I believe the two top functions, not that I use there, but the first two functions in the file are fun.try and fun.tryid. And try is basically an outer product that only gets you the pairs from the upper triangular matrix, and tryid is for the case where you want the identity as well. Because there's a lot of times where you want this kind of Cartesian product of all pairs, and it's not like you wouldn't want to dedicate two different glyphs to just the upper triangular matrix and then the upper triangular matrix with the identity included. But this is brilliant because it gives you the flexibility to do both.
I had a lot of ideas of like what you're describing, try it, like ones that include where they're the same, ones that don't include, how do you do this? And so this expresses all of those. So this is the combination. Here's range 5, right? Here's all the 2 combinations. But if I just put a 3 here, here's all the trios combinations. But if I make this less than or equal to, oh, that's backwards. Now I have the ones where we can also have duplicates. And if I go back to 2, we can have like duplicates here, right? And if I do like not equal here, now I have permutations. So here's all permutations that are 3 long of this range 5, right?
Wow.
Or if I do like -1, actually, now I have, I guess it's 5 - 1, right? So here's all 4 size combinations, permutations actually of that list.
This is so thoughtful. This is so thoughtful. Like you've put so much thought, like, because literally permutations is another one of the functions in my fun.bqn. Like this kind of stuff, and it's not covered by glyphs in other array languages. So this has me even more excited for my deeper dives into Uiua coming in 2020. I've already mentioned, it's worth re-mentioning that I will be doing Advent of Code this year in Uiua. If I have more bandwidth, maybe even more languages, but definitely Uiua is up. But this is yes, you've clearly, it's so thoughtful that like this is something that I reach for often, but there's no good way to do in existing array languages except for Uiua. Clearly,
I started with just like a permute function, it's like a permutate. I forget what I call it, permute and like choose for like the mathematical operations. And I'm like, these seem so similar. There's got to be some way these are related. Real quick though, there's also, if you pass this a monadic function instead of a dyadic one, it's prefixes.
Oh wow. Wow.
And so it'll call that. Here I'm calling box on all the prefixes.
I think it's really unappreciated. I mean, it's come up a couple times where I've tried to highlight the power that is unlocked. And not just the power, but like the simplification of the learning process in that you've removed ambivalence. You know, everything has a fixed arity. Not only does this make it an easier language to learn, but you've unlocked like an entire set of things that you can do by being able to dispatch on arity. That is just like, you know, already alone what you had there with tuples was amazing. And now you're basically showing, you know, a BQN glyph of the up arrow. It makes me think that really like the fact that N-1 array languages, Iversonian array language that exists in the world today, the other one that's not in the N-1 being Uiua, that have chosen to adopt like ambivalence. I'm not saying it's the wrong decision, but it's like, I think you've clearly like tapped into something that like should be explored more in other languages. Like, you know, my dream is a world that includes more of these like array languages that don't include ambivalence, because it also like it shows that the richness of the combinators that you're able to extract, you know, the patterns that you can, because like in it's so limiting in APL where it's like, oh, I don't know if this is binary or unary. It could be either. So we'll just wait until this gets called and then we'll make a decision. Like that's such a limiting model when like you're able to do like your partition modifier is like another great example of like you can bake so much into that. I think we talked about that
Yeah.
last time, and it's just so nice. It's like that's exactly what I want. I want to be able to apply, some splitting binary op or like on a kind of reduction or thing.
Yeah, and it's not just switching on is it unary or binary, right? It's what is the signature? Is it ternary? Is it I don't know, quaternary?
Quaternary, yeah.
Or it could do something different based on the number of outputs the function has, because functions in Uiua can have more than one output too.
Yeah.
So there's modifiers like fold that do change depending on like the number of arguments and outputs that the function you pass it have.
Yeah.
It's not like you have to learn for something like that. It's not like you have to learn a bunch of different behaviors. They're all like consistent of how the relation between number of arguments and number of outputs changes how the function behaves.
Yeah, it's also interesting too to I'm always trying to taxonomize and fit things into my mental model, but it kind of not breaks down, but like it's when you go back to like on, by, with, off, below, mapping those to the combinators from combinatory logic, it kind of breaks apart, not in a bad way, but just like you have the fork modifier, but technically it's not actually doing the exact same thing, because forks in other APLs, they bundle all the operations together, right? Whereas in your case, I guess actually fork's a bad example, because
I mean, to be fair, if you did like a lot of these modifiers would not be that much shorter. So here's width. Actually, I'll do 3.5. Here's width. Now, if I just did like 3.5 and I did by couple, and then I just did a flip after this, right?
Mm-hmm.
And now you could do this, and it's literally one character more. It's not about it being shorter. It's about it being like more expressive, because this captures like a really common pattern. And so you can learn to recognize that and how that behaves when you put something else here, right? Whereas something like this, I don't know. I think it's less, you have to do more like juggling in your head of what's happening here, I think.
Yeah. Well, so this is what I was going to say, though, is like, when you think about the analogs of these in array languages like BQN and CAP and APL, you need all the operations bundled together, whereas technically all you need here, like the modifier just takes that binary operation on the right and then returns everything on the stack. And so it's like you can look at it as a unit, which is, I'm sure, what Uiua programmers do, right? They're looking at that thing as a unit, but technically that left operation is not necessary. And so it's like technically a fork doesn't perform in both the unary and binary case, doesn't perform that final operation. It just puts both values on the stack.
Yeah.
And it's more of like a it doesn't actually change the way you need to think about it, but it's just it's like there's more flexibility there, right? Like I think it's like you've broken down the fork into its like more fundamental operations, and you can put them together however you want. Like for some case, you actually might just want them on the stack, and you're not applying some binary operation. And so, anyways, it's like more like intellectual food for thought than it is. This is going to change the way that you think about modifiers in Uiua per se. I'm not sure if you have thoughts on that.
I mean, yeah, I guess it is like a more fundamental construction of combinators, maybe. Mm-hmm. But I don't know. A lot of the design of Uiua is meant to make things shorter, not just for like the sake of it. Like it's not just golf is not one of my design principles, right? But I find that a lot of the time, being able to make something shorter makes it more expressive. Just because it's less to read, you capture an idea with less, I don't know, code on the screen. So there is a lot of stuff that's designed to make things shorter for the sake of expressivity.
Yeah. I mean, I think Aaron is like the best at articulating that line of thought. I'm in general terrible at trying to express why something that is shorter and that leads to it being more expressive is like a motivation for why you want to write code that way. But like, even when I'm in non-array languages like Python and C++, I always find myself like Python is such a frustrating language to try and write beautiful code in, because black is I experimented with YAPFI, which is like a alternative formatter that has a little bit of more customized ability with like a config file, but like I realized it was too buggy and hasn't been supported, so I went back to black. But black is so frustrating because I think it has an 80 column line limit, and you so quickly end up getting things broken onto multiple lines when you just want to read it linearly, and then you've got this big stack, and as soon as you go by, and then it puts these parentheses, and you end up going from 1 line to 3 lines, and I'm just like, I just want to keep it dense, and so I end up actually, I call it like format driven programming. I will change the names of my variables to shorten them just to avoid that line breaking, which sounds
I
like
definitely do that too.
Yeah, it sounds absurd, but like if you get this nice consistent like look, it's just easier on the eyes. It's more regular. I don't have to skip around as much. And you're saying basically the exact same thing. It's like when you can keep things kind of regular and in these little units. And it's like, I've never given the talk at a conference. I'd love to give a talk called FDD, Format Driven Development, but I'm sure that there's a ton of senior programmers that do it because it makes things easier for your eyes to track. Yeah, you're about to show us something here.
I was just going to show like this is how I end up usually writing Uiua code. I don't make my lines that long that often because I like being able to put comments for an idea, right? So a lot of my code like ends up looking like this.
So this is, we're going to take a tangent, but it was where this conversation was going to go. I was going to guide it there at some point. I've started over the last month just dipping my toes in a little bit more Uiua in the virtual meetup that I've been running for the last month that's covering a textbook. There was a calculate, log n Fibonacci calculation, and it relied on this recursive function that basically dispatches to one of 3 cases, and I ended up using the switch. We may or may not look at the code later, but I ended up having this question, like in a language that has only tacit programming, I've never ended up writing a multi-line function, but here we're staring at a function called step that starts with the signature, pipe 2.2, and then parens, and then you just got line after line after line. So like, this is idiomatic Uiua in how you, because like I imagine you end up writing these multi-line functions at some point in larger programs, correct?
The only thing unidiomatic about this, I would say, is that I wrote this several months ago before some of the existing like combinators existed. So if I were to write this again, I would probably write it a little differently. But yes, this is more or less how I like to write stuff.
And so how, like in the case where you're in a larger function and you want to refer back to some value, like do you avoid that kind of pattern and always try and keep it like linear somehow, or
that might lead into something relevant, new features that we've been exploring. Yes, if you wanted to like, if I wanted to weave some other value into here, it would be annoying. Okay. I would have to account for that. Not on every line, but on many of the lines. Because if it's something you only need to use like near the end, you could just put it at the bottom of the stack and only grab it then. But maybe that leads nice. Oh, real quick, if we're interested in like what this is actually doing, I thought I'd show it real quick. There we go. It's an n-body simulation.
Oh wow. And it is rather, pretty looking code. I love this. There's another talk I will either give or someone else will give in the future. It's the different array styles that I've kind of been, it comes up every once in a while on ArrayCast where I think from the outside perspective, everyone's like, oh, it's just this one dense format. We always see co-defuns. But really within array programming, there are several different styles. And one of them is this kind of defuns-esque where you've got short lines with a comment on every line. The comments are aligned. And it actually makes it, like, I think, rather pleasant to read. Even if you're not familiar with the symbols, you can just read the comments and get a sense of what the code is doing, right?
Yeah.
But yes, we're moving on to potential. I don't know if this is breaking news, experimental, or
no. It's been something that's been experimental for a while. It's a little bit of exploration of less tacit code, and we call it data definitions.
So we're going to get a talk called The Quest for Less Tacit in the future.
This is all experimental because it does kind of compromise some of the original vision of the language. We could argue about, we have argued about, like, in the Discord, how necessary it is to be able to just refer to something by a name that you defined earlier, right?
Yeah.
But something there's parts of this that will probably become stable in 0.15, and there's parts of this that won't. So the parts that might be, so data definitions are basically like a struct in other languages, right? So if I type tilde, and I'll give it a name, I'll call it foo, and I'll give it some fields, A, B, C. That's what it looks like in some forms. And so if I now do foo new 1, 2, 3, I now have this thing. This is just an array.
Okay.
So this is an array of boxed items. So if I put like hi, right? And then I could do like pick 1, and there's my B is box 2.
Right.
So the point of this, so if I did like foo A, and I get my 1 out, right? And that's kind of annoying to write, so I could just write like foo. If I wanted to add A and B, I can use a macro form of this. So I can do plus A, B, B. Or not. Oh, plus 4, A, B, 3. And so this is just a way of like naming fields, having like structured data that has named fields that you can refer to.
Mm-hmm.
This is not that untacit, I don't think, yet, because I don't know, it's just giving names to basically like pick 1, or well, in this case, unbox, pick 1, unbox, pick 1 and pick 0, right? Just if you have data that you need to bundle together, right?
Right.
Now I can also put this in a module. So if I do this, I'll call this module foo, and we have these nice
I was gonna say that's very, very pretty.
Delimiters. And I can do the same thing here. This gives me my same food. We could do something like give default values. So let's see this 10. This will all, I'd like to stabilize this, I think, in 0.15. What I'm not as sure about, because it is the most compromising to the vision of the language, is the ability to do this. So this is a method, and here I'm not even saying where A and B come from. I'm just saying A and B. And so when you call this, your foo that you passed in gets bound outside of the stack. It gets removed from the stack and put in a invisible place. Mm-hmm. And then when you say A, it says, okay, pull from that invisible place, take the A field, put it on the stack, pull from that place, take the B field, put it on the stack, and then it adds them. So this is like non-tacit code. And there's like a more succinct way to write this too, if you wanted to. But yeah.
So is the motivation for experimentally designing this? Well, I'll just ask you, yeah, because I'm thinking it could be object-oriented programming. It could be to reach for.
It's object-oriented, right? But it's just. It is. There are cases where it gets very complicated and annoying to have everything just on the stack, basically.
Yeah.
Now there's ways around that. But there's ways you can. What's the word? I don't know. Ameliorate the difficulties of that, but it's not perfect. So this is your like, screw it, I just want to name things option.
And so how would you use this in the sense of like I'm writing a function that has a bunch of parameters, and you're dealing with for the first 90% of some complicated thing, the first 2, and it's all linear, but then at the very end. Well, I mean, maybe not even that, because you just keep it at the top of the stack and then you reach for it. But like, there's some example where you need to reach for some value at some point, and it would have been tricky to flip. Like, so does this give you the ability somehow?
Yeah. So let me write this in a more concise way. So you can, if all you need is like one function that does that, I could do like this. So I would do foo. Actually, I'd do this. Foo takes a and b, and it does just plus a b. That's just a function. And now, if I wanted to do like, what's a good example? I could just make this take nothing, and this is just a function that adds a, right?
Mm-hmm.
And so a was bound, so I could do like, I don't know, a 5 plus. So a was bound here, but the 2 was just left on the stack. So a was bound as 1. I'll just actually go back to here, and yeah. A is bound as 1, but then I can use 2 as I want to, right? So if I wanted to do like, I don't know, just combine them together. Oh, just kidding. 2 is bound as A. 1 is on the stack. That might change. I don't know. But the idea is you can mix stack and bound values together, right? And so if you suddenly say, oh, I have some configuration option that I need to add to my function, you could do it this way. This makes me uncomfortable, right? Because the whole point of Uiua is fully tacit, which is why this has been experimental for like a long time. But
yeah, I see. Yeah, this is, so it can be used as a mechanism for basically binding a name to a quote unquote argument to a function and then calling it whenever you want and not having to worry about copying or duplicating and flipping or anything like that. Yeah. Well, do you find that you find yourself reaching for this, or when you become an experienced enough Uiua programmer, are you able to,
I don't generally reach for this. Although what I want way more is the stuff I showed before of just being able to like have structured data with named fields. I think that's less. Actually, I think it's not at all opposed to like revision of the language, right? Yeah. So my foo bar baz, right?
Yeah, I'm not sure if you saw Elias's blog post about labels and cap. You could add a basically label to columns of a matrix and treat it as kind of like titles. This is not dissimilar from that. It's like almost a subset where you're, at least in the case of
these things. So Uiua has labels, right? It's had them for a while now. So if I do like 1, 2, 3, you just write them like this. Label. These are only for debugging. You can't you can't retrieve this value, right? You can't get this like as a string or something. This just appears in your debugging. But when you make these structs or these data definitions, they appear just so you can see them. And then when I actually like retrieve it, label's removed and we just get our item out.
Yeah.
There are projects I want to do though that will use something like this. Just because you want to bundle data together and the fields aren't, it's not like a normal vector or array, right? Where the meaning of the items is uniform.
Yeah.
I want to have names for like heterogeneous collections, right?
I mean, at a certain level too, you can superficially do this by unbundling it and then just like assigning everything to some local variable name, right?
No. I mean, no, Uiua doesn't have local variable names.
Well, I mean, what happens when you assign? What do you technically call? Is that global then? I guess. Not local?
all bindings are global.
Okay.
Or at least like module local, right? But they're not like
right.
They don't go out of scope ever, basically. Other than the ability to refer to them.
Right. Okay, so yeah, replace the word local with global, and then it's superficially the same, right?
I could write like foo is, I don't know, I guess in this case it'd be box 2, and then we'd have foo bar is unbox pick 0, and then foo baz. You could just do this, right?
Yeah.
But it's a way to generate that automatically, and a bunch of other nice stuff associated with it.
Well, so I mean, my follow-up question to this then is: you say that in general you don't find yourself reaching for this, at least up till now. There are some stuff.
No,
So like,
no, there are cases where I want to reach for this.
mm-hmm.
Just named fields.
Okay.
What I don't find myself reaching for that often is like values that exist outside the stack.
Right. So I mean, but it's still probably a good question to ask though. Is what are your tips or / response? Because when I talk to people about Uiua, a lot of the sometimes APL or BQN folks, they say that it's hard for them to get away from like the mix of explicit and tacit, and like tacit inline but explicit at a higher level. What are the Uiua? Because like
Sure.
you hear sometimes in Rust they say you just have to learn how to let the traits flow through you. Like how do you learn how to let the Uiua tacit model flow through you? Because I'm sure it's one of those things. Whereas once you become more experienced with the style, it's actually not as difficult. The same way that combinators or tacit programming in any array language, to the outsider, is like, whoa, like that looks super ambitious. And it's like, no, it just takes a little bit of time and practice, and it's not anywhere as near as difficult as you might think.
There's actually a whole tutorial on this called Tacit Code about how you should think about this. This is like one of the wordiest tutorials of the whole tutorial, right? Because it's a lot of it's like philosophical. But basically the answer, it basically shows, it starts out with an implementation of the quadratic formula, right? Which the quadratic formula has 3 arguments, and it uses them in a very non-uniform way, right?
Yep.
It reuses some, doesn't reuse others, and it has them all mixed around. And so it's for a stack language, it is like a tricky thing to get right.
It is the archetype of, like, you say, oh, there's a stack language, and then they say, write this for me. This is like the thing that people point at to, like, stack languages don't do well.
Yeah. And so first it says, here's our motivating example. It's the quadratic formula, and it goes through like a way to do it that isn't that good because it's really hard to read and reason about. And then it says, it introduces this concept that I call stack source locality. And the basic idea is that the place where a value is used should be as close as possible or easily identifiable where it was created. So the basic idea is, the basic premise is just use fork a lot, because fork is structured in a way that makes things easy to read.
Mm-hmm.
So for example, if I see this minus here, and I want to know where were the values generated that are being passed to this minus? And I see, oh, there's a fork right here. And so it's the output of this, and it's the output of this. And that's it. I don't have to go I don't have to do stack juggling in my head. I just see this. This is a dyadic function. This is a fork with 2 things. And here's where its values come from. And so you just keep expanding on that. And so we end up with this quadratic formula. It's like this. And then I also say stuff like, oh, maybe split it into lines or factor out pieces of it. So here's like a thing of beauty of the quadratic formula. We have the discriminant, we have the whole thing. And so at any point you can see, okay, here's my divided by, oh, there's a fork. This is where its values came from. Here's a fork. This is where its values came from. And yeah.
I mean, if you're familiar with the quadratic formula, you can, even as a non-array language programmer, you can pick out, like there's a square root there, there's a division, there's the coefficients that like you're looking for. Sure, you might not be able to parse the whole thing, but I don't think it's actually like, especially the square root glyph is we love the square root glyph.
Well, and yeah, it's also like using planet notation sometimes. So this is for a C right here, right? We've got A, now we've got C, and here we're going past A and squaring B. Maybe some Uiua programmers would be mad that I'm not using like subscripts here, but
oh yeah, I mean, we haven't talked about subscripts yet, but we'll put that on the stack.
Yeah, there's a bunch to talk about there, but that's the idea. Is it's a combination of factoring things out into other functions, using fork a lot, using planet notation. Like I showed in that code before, putting comments on lines. I do have this thing called so if I write, say, it's a good example. Let's say I have a function and I'll do like plus times 35. Now, pretend that this is a more complicated operation. What I can do is write a comment here, and I'll say I'll define that this line gives me the sum, the product, and it takes in, I don't know, A and B. Actually, I'll put these up here. Yeah, 3 and 5. And so now I've defined, look, this is the outputs of this line, this is the inputs of this line. And if I violate this, if I just say this is plus, it'll say what? Line comment describes signature 2.2, but its code has signature 2.1. So it'll actually like hold you to this thing you've defined, basically. So I use this sometimes to define like, hey, for this line, these are the inputs, these are the outputs. You can do that with functions too. So if I made this a function, I just pop this comment up here. It'll do this. It'll keep you to that as well, right?
That's really nifty.
Yeah. So that's just a way of like annotating one for the writer and the reader too.
Yeah. I mean, it's worth mentioning too, like you've put a lot of thought into the compiler, if you will, or interpreter hints.
The tooling.
Tooling.
Yeah.
Like I haven't run into it in a while, which maybe shows that I at least know the basics of Uiua well enough. But there was a couple times where you would type something, especially with the combinators, or if you're using duplicate and swap, and you would get a message that says it's actually a little bit more idiomatic to do it this way, and you can shave off a character. And like that, as a beginner and a learner, is the like best first-in-class experience. Like I wish every tool chain, like some languages don't even touch that kind of stuff. I know Rust is decent at it, but it's just such an amazing experience. And like that's the thing, is it's something that doesn't pay dividends for experienced developers, because they're typically not going to hit that stuff. They know not to write that pattern. But for beginners and onboarding, it is like a godsend, because it's like, oh, I just learned something by doing nothing, basically, by just playing around with the language. And I didn't have to go to docs. I didn't have to go search something up. And that's the thing. A lot of times you don't know what to search, right? So how are you going to stumble across it unless if you're running, you're reading the docs from start to finish? That kind of stuff is just, a pat on the back to you, because it's, like I said, I haven't run it into in a while, but whenever I used to, it was just like, oh my God, I didn't even know that was there. That's so wonderful.
Yeah, thanks. I mean, I try to add those. There are a lot of lints like that are suggested, but either like I don't agree with them, or like they apply in some cases but not all. And so and the cases that it would apply for and wouldn't is not something that's easy to check for, so I don't end up adding something like that. There's definitely been ones I've removed because they're like, look, I'll use it in this case and it's suggesting this, but it doesn't apply. And I don't really want to add the ability to disable stuff.
That's exactly what I was thinking. Like rough gives you the hash, no QA : insert like linting thing, and
you can do that in Rust too, right? So but we were mentioning subscripts. I think I've talked about them on the array cast. So at least the basic ones, right? So what they do depends on the function. I mean, you've got your basic +1. Now, you could just write this as 1, but the whole point of this is if I wanted to do like as a unit, right? If I do dip +1, this is not going to work how I want. Whereas if I do dip +1, this is a single unit that gets dipped rather than me having to write parentheses around it. But then there's other ones that do something totally different. So like box 2 is going to box 2 items together. So this would be like J's. I think it's link in J.
Okay.
Or 3 or whatever you want, right? So there's stuff like that. Sometimes if you wanted to write like, I don't know, repeat. Here's one. Random 100. and there's a random. It doesn't change in my here, but it's changing on the right here.
Right, right.
Or if you wanted to do, you could do like repeat 10 times, or you could do repeat 10 times. So sometimes this is just about being able to write stuff shorter without parentheses, which the golfers love. But like I said before, I think there's value to that outside of golfing. And some of the times it's about enabling new behavior. So another one is like round. This is just a shorter way of writing, like round to this many decimal places or something like that. One of the newer features is experimental that I'm still working on. Hopefully it'll be some of it will be not experimental by the time 0.15 comes around, is what we call cited subscripts. And so this expresses the idea of there's two versions of this function or modifier or whatever, and they have like one you can think of as like a left-handed version and one that you can think of as a right-handed version. Now, what that means depends on the function or modifier you're doing. But here's the basic one, and it's with both. So both is going to be, I did like both plus, and we have 1, 2, 3, 4. It's going to add 1 and 2, and it's going to add 3 and 4. Now we can think of the case where let's actually do couple instead. You could think of the case, what if I wanted to couple 1 and 2 and also 1 and 3, right? Or apply a function to use 1 in both applications of the function, but then on one application use 2 and on one of them use 3. Does that make sense?
Yeah.
Does that need to make sense? So one way you could do that is you have to like move a copy of the 1 down. So if I've got 1, 2, 3, then you do what? I feel like I should know this off the top of my head. Yeah, on flip like this. This is just like an idiom that you would have to recognize, but now I have them in order 1, 2, 1, 3, and I can do my both couple, and now I'll have 1, 2, 1, 3.
Mm-hmm.
Now, instead of doing this, the more expressive way, this is experimental currently, is cited subscript. So I do normal subscript __, and in this case, I'm going to do less than. And it's going to give me this symbol. Yeah. And so this will give me 1, 2, and 1, 3. And so you could think, I could also do __ greater than, and now it's going to use 3 in both of those, and then make 1 and 2 different between them. This is a pretty common thing to want, wanting to reuse one value in a function, but make the other two, and the other two applications of the function, make them different. There's a similar thing for bracket. So if I did like bracket couple, and then I'll do like plus 1, 2, 3, 4. So here I've coupled 1 and 2 together, and then I've added 3 and 4 to get 7. Now you could want, instead, you might want to couple 1 and 2 together, but then add 1 and 3. And so you would do this. And there's the opposite as well. So this just takes some of the stack manipulation that you could be doing like at this point, and it takes the common patterns of that and moves it over here. And this is what I meant by like a left and right-handedness, right? Because it's like, am I reusing 1 and then distributing 2 and 3, or am I reusing 3 and distributing 1 and 2?
This is mind-blowing.
So these are basically alternate forms of, so both is a combinator, obviously, right? But these are like alternate forms of this combinator that are slightly different.
Yeah, where my brain is going is like, I guess it's very different than what BQN does with superscript operators, in that its modifiers are just superscript. That's just the design of whatever, the aesthetics of the language. But it does.
Yes.
Or go ahead.
Oh, I was just going to say, I mean, in a sense, subscripts, not just these, but the numeric ones too, are a kind of like hyper modifier, right?
Yes, yes, and that's sort of where like my brain was going is that, and in the same way that it changes how you can use a partially applied binary operation, like your plus subscript one. In certain cases, now you can use that where you might need a set of parentheses that is also the same thing in BQN. A lot of times there's less ambiguity because the superscript reduce is taking a binary op on the left. Not always, but sometimes. But now I'm thinking, now that you're starting to basically subscript, I don't want to say there are other glyphs, but in a sense, the less than becomes that kind of. You said you called them side subscripts.
Sided.
Sided.
Yeah.
Like you could think of a world where you're doing the same thing with modifiers, right? Like I guess your language is a bit different because everything's always prefix. But still, it's like you've opened a world of possibilities. Like, so here you're modifying the behavior of the modifier, but you could do like a whole world of things, not just with
I try to be a little conservative about how big that world is, I guess.
Yeah. That's where my mind is going. It's like exploding with like, holy smokes.
These are the examples of sided subscripts that I'm probably going to stabilize.
Mm-hmm.
There's another class of them that I'm more 50-50 about. So that's in Uiua, if you wanted to do like, if you had like 1, 2, 3, 4, 5, 6, if you wanted to do like append 1 to 4, 5, 6, append 2 to 4, 5, 6, append 3 to 4, 5, 6. Well, if we did like row join, right, you're going to get just the pairwise thing. And so you use fix for this stuff. So if I do this, here I'm fixing this to be reused over and over again. Here I'm fixing 4, 5, 6 to be used over and over again. And we get our outputs where we've got 1, 2, 3, 4, 1, 2, 3, 5, 1, 2, 3, 6, and then 1, 4, 5, 6, 2, 4, 5, 6, 3, 4, 5, 6. Mm-hmm. So using fix in this way is the normal way to do this. And the idea is basically that you could do this. Which kind of expresses that rather than moving it, I don't know, it combines the semantics of this rows into one spot rather than like rows join thing that modifies the behavior of rows, right? Mm-hmm. I don't really know if this is necessary. A lot of people really like it.
Yeah. It is. I love the fact that like you're even just exploring this stuff. I mean, I think I said it the first time I discovered that subscripts were a thing in general. Like even just on variable names, like you saw people in Advent of Code. I think Tacit Sanctuary showed once or twice that like you just like part A, part B, and the A and B are subscript.
Well, the motivation of that is that Uiua identifiers don't allow numbers.
Oh,
that was the original motivation of letting them be in identifiers. That was around way before.
Yeah.
Them being used to modify stuff was. But yeah.
Yeah. I mean, it's not a direction I think I would ever want to go or Uiua would want ever to go. But like you could think too, as one of the downsides of having fixed arity on all your symbols is that you need twice as many symbols for the same amount of behavior, modulo the fact that you can dispatch on arity, which actually does get you back some of that. But you could make the choice of like, instead of partially applying arguments to binary functions, you could just say, the glyph by itself is your unary function. Subscript 2 equals the dyadic definition. And not that you'd ever want to go there, but like it's
there's stuff like I do both plus 1, 2, 3, 4, or we have both 3, 1, 2, 3, 4, 5, 6, right? So that's maybe kind of what you're talking about. I don't know.
Kind of, yeah.
It's related. I do want to avoid trench coat functions.
literally that's in the back of my head, is like when you said I do try to be conservative, is that yeah, you don't want that, right? You want it to be an intuitive experience of when you're reaching for partition and you grab a unary operation versus a binary. It makes sense, right? It's intuitive. It's not like,
Yeah. I actually changed that about partition too.
You change that? What happens now?
Yeah, so it used to do a reduction if you pass it a dyadic, and now it just uses multiple things. So if I did like partition, I don't know, partition 1011, what's partition box? 1011 range 4. Right, there's our 0 and our 2, 3. And now if I did, I don't know, let's do both. So now we're getting, basically, this is a dyadic function. Maybe that's less clear. Maybe I'll do plus instead, actually. Or not? Oh, plus and box. So this is a dyadic function. And so basically it's taking this mask and it's masking both. It's applying the partitioning mask to each of these individually, and then passing their partitions to this function. This was not a thing that you could do easily with how it worked before, except the old behavior is not that hard to get from this. And so here we're taking 0 plus A, and that's A. And then we're also taking 2, 3 plus CD, and that's EG. Does that make sense?
Yes. Although I'm trying to think of the times when I needed, like,
I've definitely used it already. It's so you can partition multiple things by the same mask easily.
Right. I meant more.
This works with group too.
I was trying to think of the times when I've used the reduction version before, like how to spell that now. So like that, I think there's a couple different ways to solve the maximum consecutive ones, but one of them is doing the partition and then just summing, right? Like you can take the length, but summing.
You would just do like a reduction afterward, right? So if I wanted like add this all up and then join these strings together or something, that would be a reduction. And you could have done that with the old way. Now you would just do this and you would do conjoin.
I see. Interesting. I have to go check because I've used that flavor of partition a couple times in some of my GitHub repos where I have Uiua Code. So I have to go double check that hasn't changed. Interesting. Okay. You find this version comes in handy more often than the other version, because I guess you can still do.
It's about doing the old reducing version is easy to do still,
right?
With just a couple extra characters, whereas doing this thing before was not easy.
It was cumbersome, yeah.
Yeah.
And you've talked about that a lot of times. You're looking at the ergonomics, or the how practical is it to, or the cost of this, in terms of complexity.
Yeah, there's people in the YouTube chat being mad about me doing this. They want this silly idiom. I won't get into why this does this, but I see multiple people saying that, which is funny.
Yes, we do have probably. I mean, at one point I think we peaked at 30 plus concurrent viewers, which I'm not sure. If it's not the most we've ever had, it's definitely one of the highest. And probably this is the most active chat, because you've got all the. Is it Uiuans? I think that was the.
Yeah, I put an announcement in the Discord. Uiuans. I put an announcement in the Discord before this.
So yeah, I mean we got 20 minutes left, but I've been trying to kind of read, but honestly it's been so active. This is the first time that I haven't been able to like monitor. So if there was a question in here, I apologize, but save up your questions for the last 10 minutes. I definitely know, Jacob, that's not what Kai wants Uiua wins to be called. There was a poll. Are we going to talk about the poll? Because I heard.
Yeah, people are making polls every day. There is something else I wanted to talk about, though.
Yeah. And also, too, we can go a little bit longer if you're not time boxed.
I got plenty of time.
All right.
The recent ArrayCast episode where you guys were talking about indexing.
Yes.
I thought I'd talk about how Uiua approaches indexing, and you added some questions that I don't think you guys got to, which you asked about the opposite operation of indexing.
Yes. I actually I meant to make the comment that this flavor of stuff, I don't think it's ever referred to in array languages as this, but it comes like right from computer science. It's called scattering and gathering. They're like two types of operations, especially on parallel hardware, which is relevant because I work at NVIDIA, and that's what the algorithms are literally called there. Gathering you can think of as like what we were talking about. It's the pulling of values out. We're trying to index into something and get it. Scattering is the other way around. It's kind of this inverse operation where I think on the APL wiki it's called indexed assignment or something like that, where you're trying to shove values into target indices. And then I think that's what we were going to take the conversation, but we were already at like the 80 or 90 minute mark at that point. So stay tuned. But yeah, what's the Uiua story for?
I mean, obviously you've got select and pick, which are based off BQNs, right?
Yep.
But in Uiua, there's an extension to pick, which makes it capable of everything select is doing in some cases. So if I have let's say I have a matrix, right? My 5x5 matrix. And if you do like pick 3, that's going to select out that row and column, right? Or pick 2, 1. But if I do pick 2, 1, 3, 3, it's going to give me both of those. And that is kind of like a selection, isn't it?
Yeah.
And so if I copy this and I do pick, and I have to do row fix. And so if we look at the values, actually, no, let's do below. So we see the thing we're picking with is this matrix of single indices here. So we're saying for the first row, get the index vector of 1, vector of 5, vector of 3, vector of 3. So you can do everything with pick, everything that select can do with pick, although obviously you want selection as a simple concept. But when it comes to the opposite operation, right? If you want to modify or replace something at a value, we just do that with under, right? Every version of that is some kind of inverse thing. When we're talking about like how you need twice as many glyphs to get all the behavior when you have non-variaticness, that's true. But Uiua squeezes a lot of behavior out of inverses.
Yeah.
So if you've got like your, I don't know, in this case we do undersell if you do abs to capitalize. There's stuff like that. Or if I wanted to change them, I could do gap. And if I did like, or if I wanted to, if I had that on the stack, you could also do that. So it would be under dip cell. Maybe this. No, under dip cell. It's one of these. Maybe not, but anyway, you do it with under, and so there's also weird things like if I did by select, right? We know how by works. By will keep hello at the bottom of the stack, and now you would ask, well, could you invert by select? So if I did on by select, we do get our original state back of my indices and my array. But if you think about what gets passed to that on by select, it's this thing and it's the output. And so if I did the opposite and I said, no, we're not getting, if I make up an output, if I did like, I don't know, capital A, B, C, D, and I got rid of, on second thought, actually, I'd have to do it like this. This is maybe a bad example. That you could do. better example. Better example. Select absolute value, capitalize, and shoot. Now I'm trying to think of what the best way to put this. Here's a better one. 1, 2, 3, 4. By pick 1, 10. There we go. So here I have placed the index 1 to be 10. Usually this is like a, I know there's ways of doing this in other languages, but this is a pattern. Unby is like a pattern that leverages some of the under infrastructure to do weird, like asymmetric under things. I won't get into it, but basically my point is that we squeeze a lot of this behavior out of inverses.
So part of the point you're trying to make here is that in certain cases where under doesn't work, unby can work?
No, that's not true.
Okay, that's not true.
But just my main point was that all these operations are like, because I know APL has like, I think it's at.
Yeah.
Or no, amend. It has amend. Isn't that a thing?
I'm not sure if amend is the name of it, but it uses the at symbol when it's doing.
It's like set the value at this index array to this, right?
It's where, like, I'm not very familiar with it because as soon as I need that kind of stuff, I just go straight to a language with under, aka Uiua, BQN cap, because it's so much more idiomatic. And I know that whatever the name of that symbol is, the at in, actually, let's just go to tryapl.org and get the name of this thing. If we're thinking of the same thing, but it's one of these things where depending on whether you give it a value or you give it a unary operation in the form of a predicate or something, the value is slightly, or I guess it just says at. So at is the name of the app function. But it like I always end up tripping on it, and I end up not being able to use it correctly because maybe it's just my inexperience with Dialog APL when it comes to that symbol. But yeah, I find it a lot more intuitive to work with the under operation, right? You're modifying some selection and then just, replacement or doing some unary operation.
Yeah. I found that when I was looking for earlier. But yeah, this is like you put A, B, C, D into these indices in this thing. And we also have stuff like, I don't know, if you did like you can do anti-select, which is going to do, what is it, anti-select like 1, 3, 5, and then, I don't know, let's do range 10. Let's actually make these bigger. I think I have to fill this too. I do all this and then I forget how stuff works. I have it on the tutorial somewhere. Here we go. There we go. So I'm saying, what is the array that when you select from this gives this? And it's this one, right? And you could do something like this, where if you provided a fill, you say, what is an array where selecting from this gives this? And there's missing indices here, right? You can't form an array. So we fill it with this thing. So it gives this. So there's lots of stuff like that.
Is Anti new? I don't recall ever coming across Anti.
It's newer. So Anti, it's a lot to explain how it works. There's a whole tutorial about inverses. Basically, the unmodifier, right? It has a rule that the derived function from un has to have the opposite signature. So if you do a 2-1 function with 2 arguments and 1 output, it has to take 1 argument and give 2 outputs.
Okay.
That's a rule for consistency. Anti has a different rule, basically. And so like un plus is not a thing. No inverse. Anti plus is. And in this case, it's just minus. It's the thing that's like invert this thing, but with the same number of arguments, sort of, kind of.
Okay.
It's the easiest way to think about it. And so we'll have things like orient. So if I do what 2, 3, 4. If we look at the shape of this thing, it's 2, 3, 4.
Mm-hmm.
And there's the orient, which is it's like the opposite of dyadic transpose in other languages.
Okay.
So if we do like 0, 2, now we have 2, 4, 3. And then you might want the opposite of that, which is anti this, which in this case is actually exactly the same. So there we go. So anti-orient is exactly dyadic transpose from other languages, whereas orient is kind of the opposite. But
right.
there's just a lot of cases where you want the opposite behavior like that.
Yeah. I can imagine that. Yeah. Yeah. Jacob was it Jacob? Yeah, in the chat was saying that the motivating use case was base and anti-base.
Yeah, and base is actually still experimental, but I don't know. Base
is this base from APL?
It's like encode and decode.
Okay, yeah. So yes, I was just realizing when I said that that's not what they call it in.
Yeah, we do least significant digit first, so there's base 10, and I don't even have a glyph for base. But then if I do like anti-base 10, we get our value back.
Yeah, this is one of those things that it doesn't come up all the time, but then when it does, it's so irritating not to have the built-in that does it for you. It's one of the things I miss most when I'm in BQN is that they don't have a encode and decoder.
I mean, a lot of the cases we just have bits, right?
Yeah.
Which is the basic 2 version of that.
Right. Okay, are there other highlights? I want to make sure you said that you had a few things.
There's this one real quick. The backward modifier that I just stabilized.
Backward?
This is the modifier version of flip.
The modifier version of... Oh, right, because I guess you always had swap, or is it called? I keep calling it swap. Is it called flip in Uiua?
It's called flip.
I apologize to the Uiuans and the non-Uiuans that have been confused. Admittedly, it's one also of the. It's actually pretty consistent glyph-wise, but it is not consistent when it comes to both naming and also colloquially referring to this thing. I think it's in the docs called commute on Dialog APL. BQN calls it swap. And it's also confusing because colloquially it's sometimes referred to as selfie, but when it's actually I'm not sure if when Adam says selfie if he's referring to both forms of it.
I think he's only referring to the monadic one.
Okay, the monadic one.
That's an experimental thing also, is the you have to type it a weird way. Self plus. Yeah, that's an experimental one too. The modifier version of duplicate, but whether that's necessary is unclear.
That is, I guess that's interesting that I've never really noticed that that's a thing. That because whenever you need a duplicate, quote unquote modifier, you just copy the value on the stack.
Yeah.
But I guess definitely there's going to be instances when you're trying to pass some function where it's more convenient to be able to modify the function than it is to somewhere hard code some duplicate in there.
The place where you do it the most is the table usually.
Right.
As you would just write what is. And it's that people really don't like writing parentheses, because if you had to do this in a fork or something, you'd have to parenthesize this, whereas this you don't have to parenthesize.
Interesting. What are your thoughts and feelings about having to add stack versions and modifier versions of this stuff? Is that
I think generally we're moving away, and I say we because a lot of the ideas and thoughts I have about the design of the language is very much influenced by the community. We're moving away from direct stack manipulation and having to think about that, which is why there's like modifier forms of a lot of stuff. Recently we deprecated over. So over overtakes the second value and copies it to the top.
Mm-hmm.
This is easy to read, but like when you put anything else around it, you start having to juggle the, like, basically run the stack in your head of how this is influencing things. And it's just that there's modifier things that do that better now, basically.
This is interesting. So actually, I'm not sure if you go to my my Twitter. I'm not sure if you have. I think you have Twitter, right?
No, I'm not on Twitter.
Okay, well, we can't go to it, but I have that graphic. That is the combinator table from my was it Composition Intuition? I think it had a couple different titles. It was Composition Intuition 2 or The Power of Function Composition, which shows, APL cap, BQN, Uiua, Jelly, and then Haskell. And I think the Uiua column is the period at the top for duplicate, and let me go look at it myself. So the visual viewer won't get to see this because I think there's two of them, and then the rest of them I just put asterisks and say you accomplish this by kind of stack manipulation. So yeah, I have the period for the W combinator and then the colon for the C combinator. I guess the comma doesn't
correspond to
anything, which is why it wasn't there. But what I was thinking is that, I mean, now technically, and then actually at the bottom, it's not the rest of them. At the bottom for, I have for phi and for phi 1, aka monadic fork and dyadic fork, is just the forks, which is, you have to wiggle your hands a little bit. And then bracket, I have D2, and then I want to say is it both? The one that's a upright horseshoe? Or is that
that's psi, isn't it?
Or yeah, psi. But what is it called in Uiua?
You're talking about both?
Yeah, both. I think that. Yeah, this one. So yeah, the psi combinator. So these three are all here, but I guess that I don't delineate here, right? I'm kind of playing fast and loose because some of these are modifiers that operate on functions, and duplicate and flip, which once again I just called it self. I apologize once again. Duplicate and flip are stack manipulations. And I guess this needs to be updated, right? Because now with on by, I'm not sure if
I don't know that there's necessarily, I mean,
yeah, because that's the
those
thing
are
is,
like, they're more I guess they're more complicated than other languages would necessarily have combinator wise. I mean, I have that combinators page on the Uiua site, right? If I could find it here. Wait, uiua.org/docs/combinators. Yeah. Oops. Combinators. And so with all of your diagrams there, I mean, this is relatively old, but it's still relevant of like, here's what on does, here's what dip would be, and it's combining it with like multiple functions just so you can get a sense of how they come together. But yeah, there's ones here where you'd have to have like weird crossing lines, right, with like with and off connecting stuff. Even this one has a weird, just because of the way the fork works, this one has a weird crossing line here.
Yeah, I guess that makes Uiua, I mean, obviously it's a different type of language, like no one's ever combined array and stack together, but it's putting itself almost in like its own new category, because I'm not familiar with all the stack languages under the sun, but definitely the ones that I've looked at, Forth, Joy, Factor, and admittedly I've only looked at them at a surface level. They don't have these higher order, it's their combinators are stack manipulators, right?
A lot of the time what they have to do is they'll have like 1 and 2 and 3 versions of a function. They'll have like dip 1, dip 2, dip 3.
Yeah.
Or like fork, or like fork 1, fork 2, or something related to that, right? Where because they don't have like different behavior for different arities, they have to do that manually.
Yeah, I wonder what that says about functional programming versus stack programming, that kind of you're leaning towards over time, these modifiers versus these stack
It's that I
combinators.
don't want the user to have to think a lot about. I don't want them to have to juggle the stack in their head when they're writing or reading code.
Yeah.
I don't want them to have to think about, okay, at this point in the code, the stack is in this state. I want it to be more or less, I don't know, easy to read, easy to write.
Yeah.
And I don't think that, because I remember one of your old videos when you were first trying out Uiua, you're like, oh, I need this value at this place, like later in my code. So I'll put a duplicate down at this side of my code. And it's like, that works, but when you're going back to read it and then you read your whatever operations over here, you have to be like, okay, where did the inputs for this even come from? And you have to backtrack all the way through the stack to figure out what's happening.
Right.
And I don't want to do that.
Yeah, it's simple enough when you're just writing up the code, because you're just like, oh, right, I know I'm at this point. Boom, I need the value now. There it is.
Yeah, and when you have the immediate feedback of seeing your outputs, it's easy to just do stack manipulation until they're how you want them. But I want a little more discipline than that.
Yeah.
And yeah, so I mean, the stack is, and I've said for a long time, it's not meant to be a data structure. It's meant to be the way you pass values around. But I'm going even farther than that and saying, I don't know, we should move them around in this structured way so that we don't even have to think about it this much. So we're getting less and less, I guess, stack based and more just combinatory.
Interesting. An interesting develop in Uiua's arc to, on its path to 1.0. All right, so I want to make sure. I mean, I do have a final question that's very similar to the last question I asked when you were here back on episode 1 on May 10th of 2024, 10 months ago. But before we move there and then we get people to queue their questions up, are there other things I want to make sure that the stuff that you wanted to highlight that you
since the last time, I mean, about like, I think do you know about, like, we have custom inverses. There's that's been around for a while now.
Yep.
I don't have to go into that. I don't know. There's stuff like sort and last and like just convenience functions like that.
Uiua has last now?
Yeah, last.
I did not know that. I think I was literally just complaining. I don't know. At some point, I definitely in the last 3 months, I was complaining about the lack of the first last combo in array languages. Cap, they reassign the up arrow in the monadic case to be first, but then the down arrow, which I was hoping, I thought, oh, maybe this is last. And it is almost last. It's drop first, which in the case of if you have a pair of numbers, almost gets you to first last, which was at the time I was working on stuff, that's what I needed. But then I realized that drop first on a list of 2 gives you a list, not a scalar. So it is not the equivalent of last in that case. But now that is very nice. It seems like and it actually, of all the languages to have last, I would expect Uiua to be the last one to have it, pun intended, because it's a higher cost for you to add a glyph, right?
I mean, depends on how you define the cost. The other thing I'm sure you've probably seen the path modifier, right?
Yes, I saw that in Tacit Sanctuary's Advent of Code video, which when I saw that, I was like, very nice. I think I even brought it up when we were talking about, I think, queues the other day, when was it Phineas Porter was on Arraycast, and he said, oh, are there queues in any of these languages? And I said, no, but I mean,
I remember that.
Uiua does have paths. I'm not sure if you can contort a path to act as a queue for you. Probably not, but there's a queue somewhere inside there, I'm assuming.
Yeah, there's a few things like that. There's other like little like funny, I don't know, tricks and stuff. Like if you had like,
oh, so I think this is leading me directly into the last. So last time I asked, are there any cool things? Like I mentioned the BQN indices undo is technically what it's called, where inverse if you want to use the verbiage from other languages. And then you showed me a couple, the highlight being unkeep, which I thought was fantastic.
Here's one that's relatively new on the screen.
So this is slash, which is
reduce.
Is reduce. Yeah, I was going to say it's not where. That's my API.
So this is unreduce with a format string.
So basically, this is words in J.
Yeah. So you can do this with partition too. Partition's a normal way to do this. But yeah, that's just a cute little thing. I'm trying to think of there's other cute little things like that.
Is this the shortest way to spell words in Uiua, or this is just a new trick? Because I'm trying to think.
Yeah, I mean, the normal way is parbox by either P, B, B, and space. So this is 8 characters versus 6 characters. So no, this is not the shortest way. This is the shortest way.
So it's more demonstrating that this pattern can be used. That in other cases you could probably do something a little bit more involved, which is.
I'm trying to think if there's other neat little things like this.
And while Kai is thinking, for the number of you that are in the chat, if you have questions for Kai, now's the time. Or if you have things you'd like him to say on this podcast that will be aired to the people of YouTube, put them in the chat, and I will pay more attention to what is being asked and commented.
Here's one. Now. Getting diagonals with dyadic transpose in other languages.
Diagonals. I think
if you do like 0, dyadic transpose array, it's going to be the diagonal of that array, right? And so in Uiua, that would just be like anti-orient. Oh, I don't know why I'm trying to do index. There we go. There's our diagonal for that, right? 0, 6, 12, 18, 24. And in Uiua, you can do the opposite of that. And so if I do range 5, orient 0, 0. Do we need a fill? Not orient array of rank 1 with 2 indices. I think we need a fill. Fill 0. There we go. We create the array where the range 5 is the diagonal of that array.
That is rather tricky, because that is something that is quite expensive to do. Like, how would I even do that?
What do you mean?
Yeah, I'm trying to think, like, without a trick like that, you basically have to build up your zeros matrix, then get, like, an identity matrix.
Ooh.
And then
we just got a comment, not a question, but it would be a shame not to show off the Raywa demos. Yeah.
The Raywa. Is this I'm guessing another version of RayLib, not necessarily by Brian, but
yeah, this is, I started it, but it's mostly developed by the community. And so we'll do examples. Let's try Uiua. Example Flappy Bird.
Oh, I did see someone in the chat say something about Flappy Bird, but I all I saw was Flappy Bird plus a couple words. I thought potentially they were trolling. Holy smokes, folks. Flappy Bird in Uiua.
Yeah, so if we wanted to see the code for that.
Well, now here it's a race. It's a race to Flappy Bird in other array languages. Or is there...
this code does use like experimental features. One being FFI, obviously, but the other one being the data definitions. So we define this bird, which has a Y and a Y speed, and some functions for it, and like pipe state. Oh, that was the other thing about data definitions that I never showed, is that you can have tagged enums basically.
Oh, that's
so
nice.
Here's a state which has variants menu, game, and game over.
Oh, that's really nice. I mean, I think I asked you that one time. I thought I had saw somewhere that there was like an enum type or a sum type from the algebraic data type literature, and then you said, "Oh no, someone was just doing that with a macro at the time."
Yeah, so this is part of the data definitions thing, is that so each variant, like in something like Rust, can have its own associated fields.
Very
That's,
cool.
yeah, so this is just the source code for all that. It's very like, I don't know, it's not like the typical Uiua code you see because there's a lot of words going on, but
Hmm.
that I guess that makes sense because it's a lot of like um, library function calls and stuff.
Still very cool that you got Flappy Bird. I mean, is there a Flappy Bird in BQN, or is this is like
There's got to be, right?
I don't know.
What are the other examples here?
I know there's a dialogue duck in I think the APL Ray, because so now there's a dialogue APL RayLib library. There's a BQN one, which I think was the initial one. Now there's a Uiua one.
Yeah. Yeah, the community's done there's a couple of people who've been working on these bindings, and they're pretty good. There's also a library that's like because the Uiua library is like direct bindings for the RayLib functions for the most part.
Mm-hmm.
There's another library it's called Iris, and it's like a more idiomatic, I would say, sort of library for making games, but it's built on top of the RayLib bindings.
And that's like a original thing that hasn't been, ported from some other language. It's built specifically for Uiua games.
Yeah.
Interesting. Are there any Iris demos?
Yeah. Let's see if I can pull one up real quick. I don't actually have one on me. I could probably show an image of one though. Go to the top here. Do we have a picture? Maybe not. I have this library that is, if you go to the Uiua Lang organization and you go to Uiua modules, there's like a curated list of modules, and I think I've got Iris right here. So it just makes it a little simpler to do drawing and like input handling and stuff. There's examples here, but there's a Flappy Bird example in this too, and it's like simpler, I think, probably. Mm-hmm. The other thing that I've started working on is I want to make a web framework.
A web framework?
Like a back-end web framework. And so I've started working on templating. So if I go to the pad here, and here we go. So this is what the API for HTML templating would look like. And so you're writing this like sort of like a DSL, but it's just Uiua code.
Right.
And you see that this emits just a string that is the HTML that you'd be serving. And I'd have to implement like page routing and stuff like that, cookies and etc. But this is the beginnings of that.
Yeah. It's worth noting. It's worth noting too at the top. I mean, I'm not sure if on the last time this was mentioned, or we've even really mentioned it, but like the topic of package management comes up often. But every once in a while someone points out that, yeah, what I actually want isn't a package manager. It's just a way to share code and like not have to hand roll stuff myself. And just the other day, I think when I was doing the Fibonacci example in Uiua, I needed an inner product function, and I can't remember if I was asking an LLM or I just Googled it, but I stumbled across I think it was, Google search, and it was like the top result. I want to say there was like the word chroma in the username, but maybe Google Uiua inner product and see what happens. And
well, the mathy ones are going to be
Omnicar. That was the first one that came up. And all I had to do was this, git pointed at a URL. Admittedly, there was a couple warnings in using it because there was some deprecated or soon to be deprecated stuff.
They keep it pretty updated though, whenever stuff changes.
But this was like maybe I don't want a package manager. Maybe I just want, and like there's other languages with this, right? Like I know Go, they I'm not sure if you borrowed this kind of just like pointing at a git URL.
I think I didn't borrow it from Go. It's just what seemed simple to me.
Yeah, just intuitive.
And so when you import these to a project, they end up in this Uiua modules file, and it literally just clones the repo. And then there's a command. There's like a Uiua modules subcommand. I Oh,
Uiua module.
yeah. And so there's like different things you could do, like update your modules. But I don't know. One thing I get annoyed with like say Rust package management and dependencies is that if there's one little tweak I need to make to a dependency, that's not an easy thing to do. But here, because I used to have these as submodules, but I changed them to be just clones of the repo, so that you can more easily like edit and track them in your repo and stuff. So if I wanted to change one of these, I could. Yeah.
Yeah. It's I wish there was in other array languages like a nice story like you have for this. Like it's definitely not as comprehensive as a package manager, but maybe at the end of the day, like that's not even what I really want. I just want, a way to point at some code that someone else wrote so that I don't have to do it myself. And like also for my own sake, right?
Too.
Sorry?
That's why I made this too, to just keep track of like, here's like the good libraries that people have written.
Yeah. And it's for my own sake as well, right? Like in BQN, I have my own little kind of repo and I keep them in a single repo, but then like I have a script in that repo on my own, like I guess actually I've pushed it to GitHub, but like it is for updating all my other BQN repos to like have that script. And so I just like it's similar to you have a Uiua modules thing. I have like a /dep for dependency, and then my script, whenever I make changes to like my source of truth, it just goes and copies that script to every single one of my other local repos. Because like I don't have a utility that does that.
The difference is that the compiler will just do this automatically for you. So if I come in here and delete Uiua modules,
it'll just do it for you.
Yeah, and if I paste in that code that uses it, it'll automatically pull it down.
Yeah, very nice.
So it's bare bones, but I think it's usable for the things that we want package management for, right?
Mm-hmm.
For the most part. Now, when it comes to different versions of packages, that's probably not going to be the nicest thing at the moment to work with, but
yeah,
it's something you'll have to resolve yourself and update things when you need to, because there's not like semantic versioning. You're just pulling from a Git repo, but it works.
Yeah, for the easy case. I'm seeing in the chat someone mentioning Uiua-Plot as well.
Ooh, that's true. Let's see if I can pull an example. This is a good one. So here's some code that generates a plot.
Is this I know that Cap has built into their REPL a way to generate these on the fly.
So these are there's no FFI here. It's just normal Uiua image generation.
Oh wow.
With a lot of just ways of composing and creating images based on the parameters you give it, and then it constructs all the geometry and words and stuff.
Interesting.
The font rendering is there is a primitive that does font rendering. It's experimental at the moment, but
I was gonna say that looks like the 386 font.
Yeah, it's called layout. So if I do layout 50. Hello.
Look at that.
Yeah.
The first online REPL of array languages, at least, that enables you to mess around with the font. Here's a question, completely unrelated, that people complained about the color of fonts in the YouTube video that I made, the meme video. And I actually wanted to, or someone made a comment, why is the stencil glyph green? And I couldn't figure out how to change the light dark mode of the UiuaPad.
This is based on your browser setting.
Oh, and so there is no toggle. It just brings it, because that's what I went to Firefox and I had the same issue, and I was like, oh, I came to the conclusion that there was no way to do it. It's just based on the system.
I have this extension. Well, no, it's your browser has a like light mode, dark mode, adaptive mode setting, right? I have an extension that toggles it.
Oh, okay.
But even you could just go into your settings, right, and toggle it.
Yeah. If I had a thought of that, I would have made it yellow, but also too, the yellow font on white is definitely not going to pop. So I probably would have changed it, but I would have changed it to one of the at least colors consistent instead of just choosing some random green. But I apologize to the one wee one, potentially more than one wee one that I have set by my color choice of the stencil glyph.
Yeah, real quick, we've got one more of these. Oh, and I actually don't have a link. I should add a link to it here. We have documentation generation.
Oh yeah, I just saw that mentioned in the chat as well. Yeah.
Let me see if I can find it.
I'm sure in 3 seconds, if you don't, there'll be a link in the chat. Although
here we go.
Who knows?
So okay, here we go. So this is the repo. It's called Uiua Doc-Gen by Game, and they also worked on a lot of the other stuff. Like they made the original Flappy Bird version, and they're currently working on some stuff for the improving the pad, I believe. But so here, this is the repo, and here's like an example generated documentation, and it shows you the names and signatures, and it has the nice colors for stuff, which is cool.
That is cool. I mean, I think this is the first document generation tool out of any like array language. I don't think Dialog APL has anything like that, and they're the I guess language with the longest history / most folks working on it. So I mean, this kind of thing I think would be awesome, not just from like a library point of view, but I'm not sure. I'm sure you've spent some time in the Dialog docs. It's there's a lot to be improved there, like just in like the font rendering. Like I don't think they have attached to their CSS or however they've built it any APL font. So if you don't have it on your computer, which most of the times I do, but every once in a while I'm on someone else's computer, and then I'm at, why I'm on Dialog Docs if I'm not on my own computer, I don't know. But I'm there and I'm like, oh, whoa, what's going on here? This doesn't look as nice as it should. So yeah, this kind of thing is really awesome.
Yeah.
All right. I'm looking at the chat. Madeline, who's in the chat, says, I was working on a documentation generator for Dialog, but eventually kind of forgot. Yes, well, what happens when you're juggling like 17 different projects, not just working on one language, but starting a new one. All right, any final thoughts, Kai? I mean, this has been awesome. I mean, yeah, I always end up learning something in these conversations, and probably the highlight for me was tuples by far. That was extremely. It makes me want it, like, I'm curious how many of the common kind of functions that I've written in my fun.bqn library are just like exist in the Uiua language, because now like map-adjacent is one of them. You have that via stencil. Triad. That's via tuples, and it sounds like the permutation and some of my like permutation and combination functions are also via tuples. And anyways, excited to see that like potentially that library that I've written in BQN for the missing pieces is just completely available in the primitives in Uiua.
Yeah. Maybe some of them at least, yeah. But yeah, thanks for having me on again, I guess. 0.15 will be out in probably a few weeks, but you can try the existing features right now.
Yeah, absolutely. And if you want to reach Kai, probably the best place to go is the Uiua Discord, or if you want to plug anything
Discord,
else.
Or if you don't want to go on Discord, you can also just go to the GitHub too.
Okay. I will make sure to leave links for everything we've mentioned, including the Discord. Thank you so much again, Kai, for coming on. This is a blast. And probably before the next time I have you on in the future, we'll get back together again, the implementer panel, because that was a lot of fun as well.
It was, yeah.
Yeah, so we'll do that at some point in the future. And until then, yeah, thanks for coming on again.
Yeah, thanks a lot, Conor.
Awesome. Thanks for watching, everybody, and we'll see you in the next podcast.